Okay, so day one of rational expression chapter is about simplifying rational expressions. So the first thing I wanted to find is what is a rational expression? So a rational expression is really just a polynomial divided by another polynomial. It's a ratio or like a fraction looking thing where you have a polynomial on top and a polynomial on bottom. We simplify rational expressions very similarly to how we simplify fractions. When we simplify fractions, we look for the top and bottom numbers and we try to divide out a greatest common factor to reduce it. The same kind of idea applies here, especially when you have a polynomial on top and a polynomial on bottom, and both of them are just monomials. You simplify this very much like you would just a normal fraction. When you start getting into a binomial on top of a trinomial, and different types of polynomials on top and on bottom, then to find the simplified rational expression, we're going to completely factor the top and bottom, and we're going to cancel factors on top that match with factors on bottom, and you reduce it that way. One of the new things with this chapter, they're called excluded values. So anytime you're dealing with fractions, and especially when you've got variables on the bottom, one of the biggest rules in math is that you absolutely cannot have 0 existing on the denominator in the denominator. So what that means is you want to clarify or give values that you don't want the variable to represent so that you avoid a 0 in the bottom. So a rational expression is undefined when the denominator is equal to 0. So we're going to find when it's undefined. So we're going to find what numbers will make the denominator 0. And we call those excluded values. So when you're simplifying and dealing with rational expressions this chapter, we're going to have to name excluded values when we go from expression to expression. So the first thing I wanted to look at was a monomial divided by a monomial. You simplify the 56 and the 24 very much like you would a normal fraction. So 56 and 24, their greatest common factor is 8. So if you divide out an 8 from the 56, you're left with 7. If you divide out an 8 from the 24, you're left with 3. So now we've got to figure out x to the 4th is just 4x's on top, and x to the 3rd is just 3x's on bottom. So for every x on top, cancels with 1 on bottom. That leaves 1 left over in the top. So your simplified version of this expression is 7x divided by 3. Now to find excluded values, we call them EVs for short, before you even do any of this canceling, you want to explain what the excluded values are. So we look at that 24x cubed and we think, well, what number can x be in order for this whole thing to be 0? Since this is all multiplication, if x is 0, then the whole thing is 0. So one of the excluded values is 0. So we say x cannot equal 0. Or if we're just listing excluded values, we've only got 1 in our set. So B is pretty much the same kind of idea. You want to look at 36 and 15 and simplify that like a normal fraction. They're both divisible by 3, so you get negative 12, and then 15 divided by 3 is 5. So negative 12 over 5. And the y's on top and the y's on bottom, same kind of idea. If you have 5 on top and 8 on bottom, these 5 on top are going to take out 5 of the 8 on bottom, so you're left with 3 on bottom. The excluded values, we want to look before we even did any factoring or simplifying. With what value for y would make this whole denominator 0, and since it's all multiplication, we don't want that y to be 0. So our excluded value is 0. On example 2, so you're actually just factoring the top and bottom, and then we'll cross out factors after we find our excluded values. So I've got 10. If I look at the bottom, it's got 2 terms, so I look for GCF. The bottom actually factors to 4n times 8n minus 5. And so before I even cancel anything out or try to simplify anything, I look at the two factors I have in the bottom and I try to find when they will equal 0. So 4n will equal 0 when n equals 0. So one of my excluded values will be n cannot be 0. Another excluded value will come from 8n minus 5. When does that equal 0? Well, if I add 5 over and I divide by 8, one of my excluded values would be 5 over 8. So we don't want n to be 0 or 5 over 8 because that would make the denominator 0 and undefined. Once I find my excluded values, now I can work on simplifying. I can only take out this 8n minus 5 with another 8n minus 5. And since that doesn't exist, this is going to stay. But I can simplify numbers that are on the outside with single numbers up here. So 4 and 10 are both divisible by 2. So I can take out a 2 from both of them. And this is as simplified as it would be. So this is my simplified answer. If you look at example B, before you can find excluded values, we've got to factor. So p plus 4 doesn't factor. I've got 3 terms on the bottom, so I'll use the x, and that actually factors to p plus 4 times p plus 2. So my excluded values will be when each of these factors on the denominator are equal to 0. So p plus 4 equals 0 when p equals negative 4. So one of my values I don't want p to be is negative 4. P plus 2 equals 0 would be when p is negative 2. So another excluded value would be negative 2. So our excluded values are negative 4 and negative 2. Now that I've got my excluded values, I can start crossing out factors that match. Since there's a p plus 4 on top and a p plus 4 on bottom, those will cancel out. The p plus 2 is left on bottom, and when nothing's left in top, you have your invisible 1 that's always there. Okay, so several examples on the back. On example C, if I factor the top, I'm taking out a GCF. If I factor the bottom, I'm also taking out a GCF, so 40x squared times x minus 2. Before I start crossing things out, I have to find excluded values. So when 40x squared equals 0, that's when x is 0. And then when x minus 2 is equal to 0. Excluded values only come from the bottom. So you have two values we don't want x to be, and that's 0 and 2. Now that you have your excluded values, we cross out common factors. So the x minus 2 and the x minus 2, you've got this x will take out one of the two x's on the bottom, so you're left with 1 on the bottom. The 10 and the 40 can simplify to 1 over 4. So really you're left with 1 over 4x. This is your simplified expression. With that answer, you list your excluded values. So this expression only exists if x is not 0 or 2. On example D, I've got 3 terms on top. That factors to x minus 5 and x plus 2. And then 3 on bottom. If I do the x, then it factors to x plus 2 times x minus 1. So excluded values first. X plus 2 equals 0 when x is negative 2. And then x minus 1 equals 0 when x equals 1. So you have two values you don't want x to be. So this expression only exists as long as that's kind of like the stipulation. When I cross out my common factors, I've got x plus 2 and x plus 2. These are not common, so they'll stay. X minus 5 over x minus 1. On the next two examples, same kind of idea. You've got 2 terms, so you take out a GCF. When you take out the GCF, you'll have a difference of squares in the top. So the top actually factors to p plus 6 and p minus 6. The x is going to be needed on the bottom. That factors to p minus 1 and p minus 6. So my excluded values are going to come from these 2 factors. So I don't want p to be 1 or 6. There's several different ways you can list excluded values. Sometimes they're listed with these fancy brackets. Sometimes they're listed all in one step here. Sometimes they're separate. I mean, as long as you're just explaining this can only exist when this is not the value of your variable, then that's kind of the gist of it. Once you have excluded values, you start crossing out common factors. So you're left with 2 times p plus 6 over p minus 1. You can pause this and try the next one and then start the video again and see if you got it right without me. If you factor f on top, you get 6m minus 3. And then on bottom, there's a GCF of 3. And then you'll have to use the x to keep factoring. So you've got m minus 3 and m plus 2. So your excluded values will come from these two terms. If you take out a number, 3 can never be 0. So you don't get an excluded value by numbers on their own. But we have an excluded value of positive 3 because that would make that 0, and negative 2 because that would make that 0. And then from here, we can cancel our common factors. 6 and 3 are both divisible by 3. So that would become 2 on top by itself over m plus 2. These two can't cancel because this 2 is technically kind of married to this m, is kind of how I think of it. So this m plus 2 can only cancel with another m plus 2. In example G, you've got to rearrange it like we talked about in that factoring video yesterday. Rearrange it and factor it when it's in standard form. But the top actually factors to negative 1, x minus 1, and x plus 8. The bottom factors to x plus 8 and 3x minus 1. So you find your excluded values from the bottom. It's pretty easy when they're just x plus or x minus something. We know that one of the excluded values will be negative 8. If you can't see it, you can always write it out and solve the equation. So this one would be 1/3. So the other excluded value would be 1/3. So you have 2 excluded values. If I cross out from here, I've got negative 1, x minus 1 on top, and 3x minus 1. In this example, you could see the negative just put out in the front as well. These will both mean the same. In the last example, if you factor the top with the x, you get x minus 1 and x plus 3. This is using that shortcut that's talked about in the factoring video from yesterday. It's really, really nice in this chapter. The bottom factors to x minus 5 and x plus 3. So my excluded values, we don't want x to be 5 or negative 3 because that would make the denominator 0. Cross out 1 from the top with 1 on the bottom that match up. These would stay in your final expression and they don't need parentheses around them. You could say x minus 1 over x minus 5, but you always just include your excluded values when you give your simplified answer.